Hi, grade 12. Welcome to this lesson. It's grade 12 mathematics summer lessons. It's our first session, session 1, and today we're going to be introducing arithmetic sequence, and it's grade 12 online maths. It's just the head start for your grade 12 next in 2022. Okay, grade 12. Let's look at the content outline and just post some two pictures. If you can take a look, we are going to be using this textbook in all our 7 sessions in covering patterns, sequences, and series. And this textbook is Platinum Mathematics. It's a learner book, grade 12. If you want it, you can just comment on this video. I want this book. You can just write I want this book, then you drop also your WhatsApp number, then I'll just send you on WhatsApp. So we'll be using this book. Let's take a look at this content outline and of patterns, sequences, and series. If you take a look, it forms part of term 1, right? So unit 1, we have arithmetic sequence, and as I've said before in just today earlier, that this will form part of our session 1. So our session 2 will be geometric sequence, session 3 will be sum of arithmetic series, session 4 will be sum of geometric series, like that, sigma notation, practical applications of sequence and series, quadratic patterns and combinations of arithmetic and geometric sequence will form part of our session 7. So these videos will be posted on Tuesday, Wednesday, and Friday. So every Tuesday, Wednesday, and Friday we'll be posting these videos, so that you can just go through the content. If you have any question, you can drop it on the comment. I'm more than happy to assist and to help you to understand this content. Okay, let's quickly go and start with our unit 1, which is mainly arithmetic sequences. Okay, unit 1, arithmetic sequence, which is also known as linear sequence. You know, from previous grades you were calling it linear sequence in your grade 11, grade 10, grade 9, grade 8, like that, and also I think also in grade 7 you did this. Maybe you were not really aware. Okay, linear sequence or arithmetic sequence. This is our session 1, and let's start with it. As you can see, this is some sort of a revision because you did this in the previous grade, so we'll just try to be much more brief as far as possible because you already did this in the previous grades, right? Okay, what is arithmetic sequence or linear sequence? Very important question that you must ask yourself before starting a topic. So an arithmetic sequence, if you can see on your screen, is a sequence of numbers, right, whereby the next term is determined by doing what? Very important and highlighted information. By adding a common difference on the previous term. So in an arithmetic sequence, we get the next term by adding something called a common difference, the similar difference, the difference that is the same between the terms. We add that difference in the previous term in order to get the next term. So that is called an arithmetic or linear sequence. Okay, so we have the general formula, as you know from grade 11, Tn equals to a plus n minus 1 d. Very important information. We know that a is our first term, which is denoted by t1. So we can say first term because t stands for term. So when we say 1, we are saying first term. It's a, right? So a is our first term. It's fine. Our n, very important. I just highlighted this and make it red, because this is the very most important information that most students are not aware of, and are likely to make mistakes here. So n represents the position of a term, right? When we are saying the term is standing on position 30, or it's in position 30, obviously we are saying the 30th term. We are mentioning its position, right? So that is our n. It's the position of a term. Very important information. N can only be a natural number or a positive whole number. What do we mean? So we are saying n is always the element of a natural number, and it's denoted by that symbol. N is always an element of a natural number. Why? Because n represents a position of a term. And also, you know that if we are saying we can't say someone is standing on position -1. There's no such, right? There's no such. You can't stand on position -1 or position maybe 1/2 or -3/4, something like that. So n can only be an element of natural number. That is, our n is only equal to 1, 2, 3, 4, 5, 6, 7, like that, up to positive infinity, which are whole numbers, which are positive whole numbers or natural numbers. So those are natural numbers, right? So n can only be those things, right? N cannot be 0. We can't say someone is in position 0. There's no position 0, right? We don't have that position. N is an element of a natural number, and natural numbers start from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and n cannot be negative. So in most cases, when you are solving grade 12, you find maybe you're solving a quadratic formula kind of, and you get it's giving you n equals to -2 or n equals to 3, right? So on this one, you have to cancel it to say this is not applicable because n cannot be negative, right? This is correct. N is always an element of a natural number. If it's -2, there's no position -2. There's no position -2, right? So n can only be a natural number or a positive whole integer. Also, if you're solving n equals to 1/2 or n equals to 4, 1/2 is not applicable, whether it's positive or negative. We don't have such a position. This is not a natural number. 1/2 is not a natural number, so we cannot say this is correct, right? So this is not applicable. For it's applicable. So don't forget, if you are solving for n, you must check, is this a natural number? Is this an element of a natural number? Is this an element of a positive whole number? Then you must put those things so that you can get full marks. Okay, so very important. And we have our d, which is known as the common difference. You know from the previous grade, you just take the following term, you subtract the previous term. For example, just the t2 minus t1, which must be the same as t3 minus t2, the most popular formula that you know from grade 11. Okay, and also tn. What does tn stand for, right? Tn stand for the nth term. T stand for 10, a term, and n it's just n there. So the nth term, or what we call the general term, or the general formula, as you can see there, the general formula or the nth term, or the general formula of an arithmetic sequence. As we said, in an arithmetic sequence, we get the next term by adding a common difference, which is d. You can see the previous term was a. We say a plus d, we get the next term, term number 2. To get term number 3, we add d again, d plus d, 2d, we get term number 3. You see, to get the next term, we are adding a common difference up to 3d, 4d, a plus 5d, up until we reach the last term. So this is the last term, very important. Last term, as you can see, this last term is the nth term. So last term is equals to tn. In all sequence, the last term is equal to tn. You must know this information. Very, very important. As you can see, it's on the last position. It's our last term. is the same as what? As Tn, and our Tn is what? Is a plus n minus 1d. Okay, let's quickly take a look at an example and see how you can just use all this knowledge that we use here as a revision in order to enhance your understanding in patterns, sequence, and series. But today it's arithmetic. Okay, let's take a look at the worked example 1. It's our example 1 from our textbook, Platinum Mathematics Grade 12 Learner's Book. Okay, they said consider the arithmetic sequence 2, 6, 10, 14, and yeah, to infinity like that. And the first question says, what is the common difference? Okay, so we know the formula of the common difference. D is equals to the following term minus the previous term. This must be the same as term 3 minus the previous term, which is term 2. If they are not equal, then there's no common difference. Probably it might be another sequence if there's no common difference. So we know this is the first term, second term, third term, and the fourth term, right? Okay, second term is 6 minus. So always when you put the number after a negative, just put it in brackets so that you may not make mistake, right? So we're just gonna put that in brackets, 6 minus 2 in bracket. Then this must be the same as term number 3, which is 10 minus, in brackets we put 6. So we're just gonna punch our calculator. 6 minus, we remove the brackets, it's positive 2, so it's gonna be 6 minus 2. This is gonna give us 4. Then let's check this size. 10 minus, we remove the bracket, 10 minus 6, then also this is gonna be 4. Then our common difference is equal to what? It's equal to 4. So that is our common difference. So that's quite an easy one. Okay, let's so we calculated D, it was 4. That was good. They said number 2, state the values of the next two terms of the sequence. State the values of the next two terms of the sequence, right? So let's look. Here we have 14 there. So from 14 to get the next term, what do we do in an arithmetic sequence? We add the common difference to the previous term in order to get the next term. So it's gonna be 14 plus 4 as our next term. Because they need the next two terms, we're also gonna say 14 plus 4 is what? It's gonna give us 18, right? So we'll say 18 plus 4 to get the other one. 18 plus 4 is gonna give us what? 22. So 18 and 22 are the values of the next two terms of the sequence. So basically what we did, we added the common difference on the previous term in order to get what? The next term. Okay, number 3, it says determine the formula of the nth term of the sequence. Determine the formula of the nth term of the sequence. So this is an arithmetic sequence, and we know that the nth term is equals to a plus n minus 1d, right? Where our a is our first term, and we know that our first term is what? Is 2, right? So the first term is 2 there, so we just replace by 2. Then our d, we already calculated our d in question 1. Our d was what? Our d was 4. So we just basically gonna replace our a and d and get our general formula. So Tn is gonna be, our a is 2 plus n minus 1, our d is 4. Someone might be asking, why are we not replacing n? So if you take a look here, we don't know how many terms are there, right? So we don't know how many terms are there. That's why we can't replace n, because this thing is going to infinity. Hence these dots here to show you it's going to n terms, so we don't know how many terms are there. That's why we can't do that. And also this is the general formula, so mostly it's in terms of n. So we're gonna replace, and we're gonna remove the brackets there. 4 multiplying by n is gonna be 4n. 4 multiplying by minus 1 is gonna be minus 4, right? Let's group the like terms. It's gonna be 4n. 2 minus 4, it's minus 2. So this will be our general formula. Okay. Okay, let's now go to question 4. It says determine the value of the 25th term. 25th term. Determine the value of the 25th term. So what do they need? They want term 25, right? So where there is n, we're gonna replace it by 25 because the position is number 25. So our n is 25. So we're just gonna basically use our general formula, and where there is n, we replace by 25. Then we get our 25th term. So it's gonna be 4 into 25, which is 100, minus 2 is gonna give us what? 98. So our 25th term is 98. Okay. Okay, number 5. Which term has a value of 46? Okay, which term has a value of 46? So now we want the position of a term. We want n. So to say which term has a value of 46. So now we want n, right? So we want to know the term number that has a value of what? Of 46. The term number that has a value of 46. We don't know this term number. That's why they said which term has a value of 46. So we'll make our Tn to be 46. We know our Tn is 4n minus 2 is equals to 46. Then we can, okay, so we just gonna solve for n. So we can transpose our minus 2 to the other side. We take it to the other side. It's just gonna be 46 plus 2, which is 48, right? We divide both sides by 4. Sorry about the background noise. It's really quite irritating. Sorry about that. So let's solve for n. It's gonna be 48 divided by 4, and our n is gonna be 12. So which term has the value of 46? Is term number 12. Is the 12th term that has the value of what? Of 46. You can actually prove it. You replace n by 12 and you'll see it will give you that 46. Okay, let's now go to number 6. They say briefly explain why the value of n in the formula Tn equals to a plus n minus 1d can only be a whole number. Can only be a whole number. Why is it that n can only be a whole number? It cannot be just an element of any integer, just like minus 1, minus 2, or any fraction like that. Why is n only a whole number? So we said this is because n represent what? Represent the position of a term, and represent a position of a term which can only be an element of natural numbers. So this is because n represent the position of a term which can only be an element of natural numbers or whole numbers. So that's why our n can only be a whole number. This is because it represents what? The position of a term, and the position of a term, it's always an element of a natural number or a whole number. Okay, so that's the reason. Okay, let's lastly look at question 7. It says, is 72 a term in the sequence? Justify your answer. So this is quite a challenging question because maybe most students might not really know how to sort of like approach it, and because it's quite a challenging question, it needs you to understand also the nature of the terms there. So is 72 a term in the sequence? Is 72 a term in the sequence? How do we solve this, right? So if we want to know that something is a term in the sequence, we can actually determine its position, right? Its position, which is n, right? So if we know it's n, we can actually say, no, this is really a term. For example, if n is the element of natural numbers, remember we said n must only be an element of a natural number. That is, our n must be equals to 1 or 2 or 3 or 4 or 5 or 6, all those natural numbers, right, up to so forth. So that is our n. It must be like that. If it's not like that, if this 72 is in a certain position, maybe which is not a natural number, then we'll know, no, this is not a term, right? So basically what we're gonna do is we're gonna calculate its position. So to calculate its position, our Tn must be equals to this 72. We already know our Tn is 4n minus 2 is equal to 72. Then we can solve for n, right? We can solve for n. 72, this 2 goes that side, is going to be 74. 72 plus 2 is 74. We divide by 4, we divide by 4. Then our n is going to be 74 divided by 4. It's giving me 37 over 2, which is sort of like 18.5, right? 18.5. Is it a natural number? No. 18.5 is not a natural number. So therefore, we can conclude that 72, is it a term in the sequence? Let's answer the question. Is 72 a term in the sequence? The answer is what? Is no. Justify your answer. This is because our n, sorry about this. This is because our n is not the element of a natural number. That can be your reason. Just simple reason. N is not the element of a natural number. Let me write it also in words. N is not a natural number. A natural number. Or a whole number, right? N is not a natural number or a whole number. That is why we are saying no, that thing 72 is not even in the sequence because it does not even have a position. There's no position for it on the sequence, because if there was a position, n could be a natural number. Okay, great stuff. Let's now look at the worked example number 2, and it's sort of different from the first one, because in the first one you were given a sequence, an arithmetic sequence in numbers. So sometimes they might give you an arithmetic sequence in represented in sort of like unknowns. Like for example, they might give you in terms of x, they might give you in terms of any letter k, p, like that. They might use any letter and just give you, and they say this is an arithmetic sequence. And their first question, most probably in almost all questions, that they will give you this kind of sequence in terms of x, in terms of k, in terms of p, like that, and they tell you it's an arithmetic sequence. The first question will be determine that unknown. Just as in this example, they say determine the value of what? Of x. So this is an arithmetic sequence, and you must know, if I'm given an arithmetic sequence in terms of x, in terms of any letter, how do I determine, how do I solve those unknowns, right? So what you do, you have to know the properties of an arithmetic sequence, and one of the properties is that we have something that is common, and that is the common difference, right? It's a common difference. So the difference between the terms is the same. What are we saying? We are saying that term 2 minus term 1 is the same as term 3 minus term 2. The next term subtraction, the previous term, is the same as we are taking the other next term subtraction, the previous term, because these are the difference and they are common. So you use this formula always in order to solve those unknowns. This is one of the properties of an arithmetic sequence. We have common difference, just equate the difference and you solve for the unknown, right? Okay, so we know this is term 1, this is term 2, and this is term number 3. So term number 2, it's 5x minus 2 minus. I told you that after every minus sign, put everything in brackets just to avoid making mistakes. So you're going to see 3x minus 1 is equals to, what is your term number 3 is 4x plus 3 minus into, you put everything in your brackets, 5x minus 2, right? That is your term number 2. Then we can replace by negative and solve for our x, right? Minus times 3x, it's going to be minus 3x. Minus times minus 1 is going to be positive 1, right? So we have 4x plus 3 here. Minus times 5 is going to be minus 5x, like that. Minus times minus 2 going to be positive 2. Then we're going to group the like terms together and see how this goes. 5x minus 3 is 2x, minus 1 plus 1 is minus 1 is equal to 4x minus 5x is minus x, right? 3 plus 2 is what? It's 5. Then we're going to group the like term. X is going to go that side, minus 1 is going to go that side. So we're going to have 2x plus x. When x transport to the other side, changes its sign, right? So here we have 5 minus 1 going that side, 5 plus 1, like that, because it was minus 1, it goes that side, plus 1. So here we're going to have 2x plus x, which is 3x, is equals to 5 plus 1, which is 6. Easy to solve x. We divide both sides by 3, we divide both sides by 3. Therefore, our x will be equals to 6 divided by 3, which is 2. So you have solved for your unknown. Very important. In an arithmetic sequence, how do you do it? You equate the difference because they are the same. The difference are the same. You replace. When you replace, the only mistake that student can make is here with after the negative sign. Just put everything in brackets and remove by negative. Do it slowly but surely. Then you'll definitely get the correct answer. I hope you understood this. Okay, let's look at question 2 now. Okay, question 2. So they're telling you if x is equal to 2. So it's quite funny because we already know that x is 2. We have proven it just now. But they're telling you if x is equal to 2. So they're basically telling you the answer now. If x is equal to 2, they're just verifying our answer. Determine the values of the first 3 terms of the sequence and determine the formula of the nth term of the sequence, right? If x is equal to 2, determine the values of the first 3 terms of the sequence and determine the formula of the nth term, right? Okay, we have term 1, term 2, and term 3. And both these 3 terms are expressed in terms of x. Term 1 is 3x minus 1, term 2 is 5x minus 2, term 3 is 4x plus 3, right? If x equals to 2, let's determine the first 3 terms. Where there is x, we're just going to substitute with 2, sorry about that, with 2, then we solve for our first term there. 3 times 2, 6. 6 minus 1, 5. So 5 is our first term there. So where there is x, we're going to replace by 2 and we see how it goes. 5 times 2, 10. 10 minus 2, 8. So that's our second term. So this is 4 into 2 minus, it's plus 3. 4 times 2, 8 plus 3, 11, right? So these are our first 3 terms, 5, 8, and 11. So they also said determine the formula of the nth term. Determine the formula of the nth term. We know Tn equals to a plus n minus 1d, right? What is your a? Your a is your first term, right? What is your first term is 5, n minus 1. Your d, let's go and calculate d. To calculate d, we said the second term, the following term minus the previous term. So the second term is 8 minus the previous term is 5. This is gonna give me, okay, so don't forget you must put everything, like after negative just put it in brackets so that you might avoid making mistakes. Always don't forget. So 8 minus 5 is gonna give me what? It's gonna give me 3. So my common difference is 3. Then I'm gonna replace it there. Then sorry about this. So it's gonna be 5 plus 3 times n, 3n, 3 times minus 1 minus 3. Then it's gonna be 3n. 5 minus 3 is 2. So this 3n plus 2 is my general formula or my nth term of the sequence. Okay, great stuff. We are still continuing with the arithmetic sequence, also known as linear sequence. This is the other example, and just trying to show you all the possible questions that they may give you in an arithmetic sequence, so that you may be able to grasp and conceptualize this content, so that you'll be able to solve all possible questions that they may give you in an arithmetic sequence. Don't forget, we are still using Platinum textbook, and it's a learner book, grade 12, and this example was taken from there. Okay, says the sixth term of an arithmetic sequence is minus 5. So I'll just say term number 6 is equals to minus 5. And the sum of the second and the eighth terms is minus 2. So the sum of the second is term number 2 plus term number and the 8 terms, right? And the 8 terms, so it's term 2 plus term 8 is equals to what? It's equals to minus 2. So they said determine the first 3 terms of the sequence. Determine the first 3 terms of the sequence. They want term number 1, term number 2, and what? And term number 3. Okay, how are we gonna solve this? So every time if you are given sort of like in this expression, like term number 6 is equals to what, term number what is equals to what, you have to express those terms in terms of A and D, right? You have to know, how do I express terms in an arithmetic sequence in terms of A and D? For example, we know that term number 1 is A, right? Term number 2, we get the next term by adding a common difference on the previous term. It will be A plus D. Term number 3, we go on term number 2, we add D, so it will be A plus 2D. Term number 4, it will be A plus 3D. Term number 5, you can see it will be A plus 4D. You can actually see a certain trend or a pattern in an arithmetic sequence, in a way we express this arithmetic sequence in terms of A and D. If you can see, term number 2 is A plus 1D, right? Term number 3 is A plus 2D. Term number 4, A plus 3D. You can see the trend. Now to say, okay, if it's term number 4, I will say A plus 3D. You can try to sort of like memorize that trend. Also, if you are given term number 10, you can say it's A plus what? 9D, right? If you say term number 100, it will be A plus 99D. Term 323, it will be A plus 322D. So that's the trend that you can see from these things. So once you know the trend, you'll be able to solve these questions. Okay, so let's actually go and solve them and see how it goes. Okay, so we have term number 6 is equals to minus 5. We can express term number 6 in terms of A and D. How are we gonna do that? Term number 6, we know according to the trend it will be A plus what? 5D. A plus 5D equals to minus 5. So this is our equation 1, right? Term 2, what is your term 2? It's A plus 1D, right? That's our term 2. Okay, let me write it like that. Plus term 8, it will be A plus what? 7D is equals to what? Minus 2. We can actually see there is like term A plus A is going to be 2A D plus 7D is gonna be what? 8D is equals to what? Minus 2. This is our equation 2. So that is our equation 2. What next? What can we do? We can use the elimination. It's the fastest method, or you can use the long method, which is sort of like simultaneous. So it's better to use simultaneous because elimination sometimes can get you confused and all that, right? So but basically with the elimination method, you just check these two equations and you see which equation, if I want to make some of the things the same from this equation. For example, I want to make this to be the same as this one, which is 2a, so it's basically multiplying all by 2. Then I subtract the two equation, 2a and 2a cancel, we are left with those. You'll be able to solve for d. But let's just use simultaneous because mostly they don't normally use elimination. So let's use simultaneous. We'll say from equation 1. So from equation 1 we're gonna get our equation 3, right? From equation 1, which is a plus 5d equals to minus 5. So we're gonna solve for a. Our a will be minus 5 minus 5d minus 5 minus 5d. When I take this that side, it's gonna be minus 5d. So this is my equation 3, right? So from equation 1 I managed to make equation 3. Then I'm gonna substitute equation 3 into equation what? Into equation 2. Substitute equation 3 into equation 2. So where there is a, I'm gonna replace by what? Minus 5 minus 5d. So into my equation 2. So it's 2, where there is a is minus 5 minus 5d. I replace plus 8d is equals to what? Is equals to minus 2. Let me replace by 2. Minus 10. It's going to be minus 10. 2 times minus 5d minus 10d plus 8d is equals to minus 2. Is equals to minus 2. Okay, so minus 10d plus 8d is going to be minus 2d is equals to minus 2. If I take minus 10 to that side, it's going to be plus 10, right? Minus 2d is equals to 10 minus 2, it's 8. Divide by minus 2, divide by minus 2. Then my d is going to be 8 divided by minus 2, which is minus 4. So I got my d, right? Our d is what? Is minus 4. Let me just put it some on top, maybe using a different color. Let me say, maybe blue. D is equals to minus 4, right? So that is our d. So to get our a, we're gonna say we just return back to any equation that is quite simple. Then we're gonna solve for a. So d is minus 4. I can go back to equation 3 and substitute my d as minus 4 and get my a, right? So it's gonna be a is equals to minus 5 into minus 4, right? So minus 5 into minus 4. So I'm gonna use a calculator for this and get the answer. But minus 5 times minus 4 is positive 20. 20 minus 5, it's gonna be 15. So also on the calculator, our a is 15. So let me also put it on top. A equals to 15, right? So if you check, we managed to get the value of a and d using simultaneous equation. But the most important part was basically to express this in terms of a and d. Like term 6, you must know the thread, it's a plus 5d. Term 2, it's a plus 1d. Term 8, it's a plus 7d. Then the rest of the thing is just the algebra part. But the key thing now, it's how you have to know how to express those things in terms of a and d, right? Then we can now get the 3 terms that they need. I don't know where I will put this because this space is already full. Let me put it here. Our a is our term 1, which is 15. That's our term 1. Term 2, we know to get the next term we add the previous term. We add the common difference on the previous term. So it's will be 15 plus our common difference is minus 4. Then this will give me what? 11. 15 minus 4, when I remove the brackets, is 11. So 11 minus 4, 11 minus 4 is gonna give me something like 7. So my term number 3 will be 11, the previous term, plus minus 4, which is the common difference. This will give me what? This will give me 7. So 15, 15, 11, and 7 are the first 3 terms of this sequence. But most importantly, I wanted you to know the trend of how you can express those terms in terms of A and D. Okay. Okay, grade 12. I've been showing you many different examples on how to solve arithmetic sequence. It's time for us to engage. It's time for you to engage in this lesson. So you can pause the video here and look at this question. I call it challenge question activity, and let's see who can solve it. It's only 2 questions, 7.1 and 7.2. Just drop your answers on the comment section, then I will reply from there. So you can pause the video and answer and try to answer this question. Okay. Okay, this marks the end of our lesson. Thank you for joining me today. Thank you for watching. This was session 1. It's the first session of our many sessions that we're gonna be having, and I hope you learned something. So tomorrow we'll be doing session 2 at the same time, 2 o'clock. I'll post the video, and just ensure that you engage. If you have any question, drop them on the comment section. If you like this video, like it, and let's see how far we can go. Okay, so enjoy the rest of your day. That's all for me. Goodbye.